Far from Earth, deep in the Saturnian system, a frozen world is rewriting what scientists thought they knew about life itself. Its name is Titan, Saturn's largest moon, a place so alien yet strangely familiar that NASA now calls it one of the most promising worlds for discovering life beyond Earth. And in 2025, the data streaming in from telescopes and upcoming missions has revealed that Titan might not just resemble Earth in appearance. It could be chemically alive. For decades, Titan was hidden under a thick orange haze. But in recent years, the James Webb Space Telescope has finally pierced that veil. Webb's infrared eyes detected chemical reactions in Titan's upper atmosphere that stunned scientists. Unstable molecules that shouldn't exist unless something is constantly producing them. These reactions include the breakdown of methane into radicals and hydrogen cyanide, the building blocks of organic life. On Earth, these same molecules were key to forming amino acids billions of years ago. That means Titan could be running its own version of prebiotic chemistry right now. Unlike Mars or Europa, Titan doesn't need liquid water on its surface to stir the ingredients for life. Instead, its seas of methane and ethane act as a different kind of solvent, one that could sustain molecules capable of forming cell-like membranes. A 2025 NASA study revealed that under Titan's extreme cold, hydrocarbons can assemble into flexible, stable structures called azotosomes. They behave much like living cell membranes on Earth, but without water. This discovery broke the most fundamental rule of biology, that water is required for life. On Titan, methane might do the job instead. At Titan's surface, temperatures plunge to minus 179 degrees Celsius, and sunlight barely reaches the ground. Yet Webb's new thermal scans show dynamic weather patterns. Methane rainstorms sweeping across the polar regions, feeding massive seas like Kraken Mare and Legia Mare. These lakes are so vast that they hold millions of cubic kilometers of liquid hydrocarbons. And they don't just sit still. Tides, driven by Saturn's gravity, make their surfaces rise and fall, and some regions even appear to bubble from within. Scientists now believe these bubbles could come from nitrogen gas released during chemical reactions below the surface. But perhaps the biggest breakthrough of 2025 came not from space telescopes, but from ground observatories on Earth. The Keck telescope in Hawaii detected something that changed everything: faint infrared signatures of carbon dioxide and carbon monoxide above Titan's North Pole. These gases suggest that Titan's methane might be breaking down faster than previously thought, replaced by new organic compounds generated through atmospheric chemistry. That process could mirror the early Earth, when ultraviolet light and volcanic gases created the first organic haze. If this is true, Titan isn't just a frozen world. It's a living chemistry lab, recreating the conditions that led to life on Earth billions of years ago. NASA's Dragonfly mission, scheduled to reach Titan later this decade, is being prepped with this in mind. Engineers are updating its sampling instruments to search for complex organics that match what Webb and Keck are now detecting. Dragonfly will not look for life directly. Instead, it will analyze soil and atmosphere chemistry to see how far Titan's molecules have evolved toward lifelike behavior. And with these new signals from 2025, the mission could arrive at the most promising site ever targeted for extraterrestrial chemistry. Scientists now believe Titan's surface might hide subsurface pockets of liquid water beneath the frozen crust. Radar studies suggest that these underground oceans could mix with ammonia, keeping them from freezing solid. The interaction between those subsurface waters and the methane-rich surface could create a powerful chemical gradient, exactly what's needed to fuel prebiotic reactions. In short, Titan might not only have the ingredients for life, it might have the energy source to spark it. The new models built from 2025 data show that Titan's atmosphere behaves like a slow-motion version of Earth's. It has clouds, rain, and evaporation cycles, but stretched across years instead of days. A single methane storm can last for months, reshaping dunes, carving valleys, and filling entire basins with liquid fuel. When the rain stops, Titan's haze thickens again, creating that mysterious golden glow that hides so much of its surface from view. But even through that haze, NASA scientists now see evidence of dynamic geological activity. There are hints of cryovolcanoes, icy mountains that may occasionally erupt with water and ammonia instead of lava. Those eruptions could replenish the atmosphere with fresh methane, explaining why Titan's atmosphere hasn't run out of it over time. Without active processes like these, Titan's methane should have disappeared millions of years ago. The fact that it's still abundant means something deep below is continuously producing it. What's even more surprising is what scientists recently found in the latest spectral data from 2025. Titan's massive dunes, once believed to be made purely of frozen water ice, may actually contain rich layers of organic dust. These dark particles, scientists now believe, form high in the atmosphere when ultraviolet radiation from the sun breaks apart methane and nitrogen molecules. The resulting fragments recombine into complex hydrocarbons, which slowly drift downward through Titan's thick haze. Over time, they settle on the surface like a chemical snowfall, coating the dunes and plains in a dark, tar-like powder. This means Titan's landscape is literally covered in organic material, the same carbon-based chemistry that, on Earth, eventually led to life. It's as if the entire moon is frozen in the middle of an ancient biological experiment, waiting for the right conditions to continue. And that spark might not be impossible. At NASA's Ames Research Center, scientists recreated Titan's environment in a lab, replicating its freezing temperatures, nitrogen-heavy atmosphere, and methane rain. When they exposed simple gases to ultraviolet light, something remarkable happened. Complex molecules began to form spontaneously. Some were tholins, reddish organic solids that may explain Titan's strange color. Others showed early amino acid-like behavior, the foundation of proteins, and by extension, life itself. In other words, what NASA has uncovered in 2025 isn't life yet, but chemistry that behaves as if it wants to become alive. Titan might be showing us how life begins before it truly starts. Titan reminds scientists that life may not require Earth-like conditions at all. It might arise anywhere the right chemistry exists, even on a world so cold that metals would shatter like glass. As the 2025 data pours in, the line between the living and the chemical grows thinner. NASA's team believes that when Dragonfly finally lands there, it may witness a form of evolution in progress. Not biological evolution, but chemical evolution, the slow assembly of life's ingredients into something entirely new. Titan, once thought to be just another moon, could be the key to understanding how life begins anywhere in the universe. If these findings hold true, then the search for life has already reached a turning point. Because somewhere, 1.4 billion kilometers from Earth, in a world of orange clouds and methane rain, the universe might already be experimenting with life's next form.